All right, once again, welcome to the IMTS. I dropped off the S, Creators Lounge. And you guys are out here. This has been a fabulous, fabulous conference, a must-attend event, 2 years. We will see you then, too, as well. All right, in the house, we've got two Hitachi Vantara professionals. How about that? Vignesh and John, how are you doing?
Doing great, Scott. Thanks for the opportunity.
Doing well?
Fantastic.
All right,
man.
man.
It's been a great show.
So for the listeners out there, let's just sort of level set right now. Give us a little background, Vignesh.
Absolutely. Yeah, I'm Vignesh. I head the manufacturing and consumer goods business for Hitachi Vantara. 25 years predominantly in the manufacturing and the discrete and the process manufacturing areas.
Oh, very good. All right, John, you're up next. Give us a little background. Bring the mic forward just a touch because we want to hear your voice a little bit closer.
So I'm the Global Director of Marketing for Smart Spaces and Video Insights. Predominantly for the past 10 to 12 years, I've been in the IoT, smart building, smart city space, working for blue chip companies such as Siemens, GE, and now Hitachi.
So we're gonna dive into that. But beforehand, are you guys having a good conference?
Oh, wonderful. Wonderful. It's good to see all these people come out. It's been a great conference, great learning. Things have moved only forward in the last 3 to 4 years that we've missed being
It's insane. The velocity, the speed, the amount of change that has taken place. Now, of course, we've hadn't been here for about what? 4 years? Yeah, I think it's 4 years. Sorry, I'm dealing with my headset. And so that to me is always the part that gives me sort of like the wheelies, because I'm just telling you, because of the speed is so fast. Mm-hmm. And who knows where we'll be in 2 years, but it's not going to be here. That's for doggone sure. Now let's start off the conversation with you. And there's been some buzz. There's been some conversations that roam around, let's say AI, computer vision, all of that stuff. Talk to us a little bit about that.
Absolutely. I remember 25 years back, a couple of my friends who were doing their theses on image processing, trying to teach a learning algorithm what is a cat, right? Fast forward 25 years.
Hold. Don't gloss over that. What is a cat?
Yeah, trying to help a computer identify an image that is of a cat, to know that it is cat, right?
Oh.
Fast forward 25 years, now we have computer vision, which basically means the ability of image processing, or computers, or rather cameras, to do things that a human eye can do in an automated fashion.
Yeah, but that requires an AI platform to associate it with, because you just don't say, hey, that's a cat. There's got to be some machine
learning and artificial intelligence built into these things, so that the computers are able to do what a human eye does. As simple as that. It's very simple. If a human being has fallen down, you and I can see that and say and run for help. How do you teach a computer that somebody is fallen down or somebody is crouching to fix something, right? And today we have systems that have learned those things and are being used in manufacturing plants, in mines, in smart cities, smart spaces. It's pretty amazing what 25 years has done, and we are seeing amazing capabilities and applications in this field.
See, I didn't know that.
So
that's amazing.
Absolutely. Here at IMTS, if you go to our partner booth at AT&T, we have a computer vision system that tells you how a plant could be visually automated from safety perspective. When somebody is overreaching into an area that they shouldn't be, we can immediately alert for safety issues and can avoid any accidents from happening.
So it's at that point. Now, John, let's talk about some smart space. It seems like that's a good segue into smart space. First, define what smart space is. What is it? And then why is it important? What's the value there?
Got it. So with smart spaces, we utilize that computer vision, and there's really two key elements to it. There's a hardware element and there's a software element to that. And we take the hardware and the software element to combine them to really develop the solution. So when I talk hardware, that's things like your gateways, your your sensors, your LiDAR, your smart cameras, things like that. And from your software perspective, from a Hitachi, we have a video, we have an analytics suite, we have a visualization suite, multi-feature video search, and also a facial recognition platform as well. And so we take those and we look at the various challenges and strategic initiatives that our customers have, and we put those together to really design that solution. And so as an example of that, as he was mentioning.
Yeah, you got to give us sort of, I get it. You give us a use case. What does it mean? What's that value? What's that nugget of benefit?
Really, so it rolls up into 3 key buckets. So the first one is safety and security, and there's a million different use cases within safety and security. There's also operational efficiency and effectiveness, meaning how do my teams operate more efficiently, be more proactive in their approach to how they maintain a space or the assets in that space. And then there's also experience. So how do you increase the experience of individuals that work in that space, operate in that space, or even come back to that space to, whether it's for revenue purposes or just to have them increase the usage of the space. And so like I said, there's a lot of different use cases that roll up into those 3 core buckets. It's really, the beauty is the eye of the beholder. How do you use this tech to either solve for that or contribute towards those?
Absolutely.
So the question I would ask, I always put on my, hi, I'm a company hat, right? So the question I would ask is, I get it, smart, yeah, good. Yeah, technology's there. Yeah, we can do it. I don't even know where to start. How do you go into an organization, Vignesh, and say, oh, right here, or we evaluate it this way, or we see gaps here? Just how do you do that?
Absolutely. Let me take an example, right? We have an aluminum mill in Tennessee.
Got it.
That where we are working. Everybody is now aware of advanced driver assist systems. For example, car that keeps in a lane. When you move away from your lane into slowly, if you're sliding into the next lane, you get a warning, right? Now take that as a use case and think, how could it apply to an aluminum rolling mill? What happens is that from time to time, when there is calibration issue in the roll mill, the aluminum starts extruding and becomes a telescope. It's not a cylinder anymore. It just becomes thinner on one side, thicker on the other side, right? You do not want that. Now take this lane discipline or the lane keeping technology that is using radar and computer to keep you in a lane. Now, if I apply that to a roll mill, I will precisely know the moment the aluminum starts extruding on one end, I can do the calibration and avoid a major issue in production, right? It's simple things like these that we have ability to apply in industrial situation that is making things much, much easier for us to run a very, very robust plant.
But again, John, you're going to come into my office, you're going to come into my facility, and I'm going to say, hey, I hear what you're saying. I've looked online, I've read the literature, I know what's going on, and I'm interested. Do I come with the understanding that saying, hey, I'm having a production line issue here, and I think that your solution, or how to, or do you just come in and say, hey, let's look at this whole thing holistically, and then focus on areas that I can achieve success? What's that strategy like?
So we always try to do the one Hitachi approach. Obviously, we have a lot of different types of solutions and things we offer. But from a smart spaces perspective, when we go in, we learn about what are the top 5 things that are keeping you up at night in regards to, your operations, your organization in general. What are you trying to solve for, or what are you trying to work towards? And learning about those challenges and then designing a solution around that. So I'll give you an example.
Yeah.
So a lot of these manufacturers that we're working with today, that we're having these really great engaging conversations with, safety and security has been a big topic. As an example, there's a lot of manufacturers here who have crew members that happen to have injuries, and that's from things along the lines of putting their hands where they're crossing a boundary when a machine is on, getting their hand chopped off or getting some type of injury, things like that. So utilizing LiDAR or smart cameras together, in some cases, really designing a boundary around that. So when their hand crosses into a space that it's not supposed to be at, the LiDAR could pick that up because of the boundary that we've outlined for it. And it monitors that at all times. And that machine could shut off from the second that their hand crosses into that space. Or If they even get close to it, there could be warnings and alerts that could get sent to supervisors via text message or email to let them know that, hey, there's somebody who's crossed into a restricted zone that's not supposed to be there. Here's a picture of them. Here's an email of them. So proactively, they could take all of this and adjust their training and look at their operations holistically. Now, as I talked about earlier, is that as we start to go down this rabbit hole, more and more solutions or more and more challenges are coming up that we get to look at holistically what else Hitachi could do for you. And then we start to have that conversation together.
See, and I like that, because all of a sudden, if in that situation, that example, you're identifying, hey, here's a hazard. It's a human component. Let's just keep it at that. It's a human component.
Right.
And for me, if I'm working that line, I know that I've had that conversation, like, don't go here. And if you go here, this thing will shut down. It keeps you safe. So I'm hypersensitive. I'm, in essence, safer just because of that conversation, period.
Absolutely.
Another good point to that is that from an analytics perspective, so we can look at not only, the warnings and the alerts and having something be more of a reactive approach, but looking at the analytics, you could take your teams to be more proactive in their approach. So say, for example, you could look at holistically over the course of a month, we'll just say. You could say on the first Monday and Tuesday of every single month, there happens to be more individuals that cross into a restricted zone or not. So they can look at that and go back to their safety and operations teams and say, what is going on in the first week of every single month on Monday and Tuesday that causes more accidents to happen by somebody crossing into that zone? So they could dive deeper into those first 2 days, as an example, and kind of look at it holistically and proactively approach it and say, it's a people problem, it's a training problem. And again, we could apply that type of situation to all of their operations to either reduce CapEx, reduce their OpEx expenses as well, increase the safety for their people, or just the experience in general.
Okay, this is sort of off topic to a certain extent, but if I'm an insurer and I know that you're a safer sort of organization and a facility because you put in this technology,
Absolutely.
I'm
Less
going
liability.
to say, hey, here's I'll cut you a deal.
Absolutely. It's less liability when you do that,
Yes.
right? And, we have taken that same use case. So, John, when you put in a computer vision, right, then the applications become numerous. For example, a kilometer or 1,000 feet under the ground in a mine, we are using computer vision to identify the quality of the ore and to help the make decision whether they should be continuing to mine in a given spot or they should move. Otherwise, what used to happen is that they would collect the ore, it will come up, somebody with the knowledge will analyze the ore, and then they say, no, this place is no good, move to the next spot. Probably you would have lost 2 days. Now it's happening real time underground, 1,000 feet under the ground. But the beauty of this is, once I put the system in, now I know, this is only doing one thing, but the computer can pick up, the cameras can pick up so much more. So now we are using it to monitor the conveyor belts and say, when is the conveyor belt going to need a maintenance? The same camera.
So you're identifying a potential failure.
Absolutely,
within it.
Yeah. So we have now trained it to do asset performance. Now, the third aspect of it, safety and security. If people underground are not wearing PPE, it can pick that up. If somebody is not wearing a glove, somebody is not wearing a helmet, it can immediately pick it up. One camera, 3 uses, right? So this is precisely how computer vision is changing operations in real time in the industrial world.
Okay, so I'm a maintenance guy. I am. I've done it before, and me personally, every time that I have to perform maintenance on an asset of some sort, I'm listening to maybe a vibration, or I'm seeing some heat, or just whatever. It doesn't sound right.
Right.
How does computer vision deal with the fact that, how do you see that?
Yeah, essentially it's the movement of the parts, and it also notices the vibration on the belt, the conveyor.
There you
itself,
go.
Right?
There you go. There you go.
The change.
Yes.
The moment it starts, moving more than the configured range, that it's in for some kind of a maintenance.
Got it.
Right? So that's the kind of thing that we are looking for.
Go ahead, John.
So something else that kind of piggybacks off of that, not only from the video perspective, But we also have a product, as an example, it's our visualization suite. It's more or less that single pane of glass dashboard that you could look at your graphs, your charts, not only for video data and those insights and analytics as well, but if you want to bring in building data, IoT data, other sensor data, and holistically put that on one dashboard.
Absolutely.
And when you're doing these asset performance, or when you're doing some type of operations maintenance, and you have to deduce what you need to do next, instead of going between multiple systems, logging into different portals, things like that, bring it into one dashboard, look at everything holistically, all the various types of data points to do your analysis. And then from there, you can make a conclusion of what you need to do.
But then again, you can also say, hey, I don't need to look at your data. You're Vignesh. You look at this data, and then you're John. You look at this data, right? And I'm Scott, and I look at this. Then you can, segment that data that is meaningful to me, you,
Right,
and everybody else, and then eliminate the complexity. Don't make me do more than I have to. Expel as much gray matter as I possibly can to understand what's going on.
Right.
Then there's that analytics
Absolutely.
that sort of back it up and saying, this is not good. Whatever.
It's
Red
looking
light,
at the
green light,
right
yellow light,
data.
whatever.
It's
Scott,
looking at the right data.
If I can go back to that aluminum factory, right?
There you go.
Where we sensorized 500,000 tags where we are collecting data from, which means every single machine on the floor is sensorized and we are able to collect data. What does it do with all that? What do you do with all that data? Now I know any given point in time, any given location within the plant, what machine is operating, what is the risk profile of that safety and risk profile of that particular location at that moment. I can put a dashboard and say, this is a high risk location, so please stay back 10 feet. If the machine is down, then I can say, this is safer space to be for maintenance purposes. Now, tie it in with the computer vision. You can catch the exceptions before they happen, while you are also giving the profile of the spot, saying that this is a high risk location, stay away. And going back to your insurance conversation, that defines a safe workplace.
I understand. It's sad, but I do understand. Couple of questions. One, what about that potential pushback on saying, hey, Big Brother's watching me all the time? Do you get that?
Absolutely. We get that. But then when you help people understand, it's better than losing a finger. I had one of our, a customer walk in today, and they were talking to John about it, that they had an incident last week where when a machine was operating, somebody did not realize, they put their hand in and lost a finger, right? So the benefits outweigh the Big Brother outlook that, the kind of fear that it generates, but then it's for everybody's safety. So that's where we draw the line.
So here's good, and you have to be safe. I don't care, and whatever the tools and techniques and strategies, yes, you need to deploy them. You need to keep safe. This sounds great. It's all fantastic. What's the pushback? Why would somebody say, "Man, no, not me"?
You know what? The pushback sometimes that we get. Like I said, there's been some individuals that are more that privacy, but we have a solution for that. If people don't want their identifying,
Good point.
Look,
I didn't even think of that either.
if they didn't want somebody to
Figure that out.
identifying features,
Yeah.
there's two solutions we have. So there's the LiDAR, which basically, again, it's a 3D representation based on light reflecting off of an object. And it just looks like there's no identifying marks in it. It just looks like a 3D person. You can't tell it's me, you, him, anybody.
Right.
Or we have a software overlay on top of the video feed where we have the ability to put we could blur them out. We could put a blue mask over them so you don't see it, because we don't care who it is. We care about the action.
Exactly.
And so from there, at that point on, we said, it's fine. We won't know it's you. We'll just know a 3D person put their hand in there, or somebody with a blue mask put their hand in there, and that we care about the action, not the person.
Okay. Well, I'm all in. I don't know what that means, but I'm all in. But now let's sort of think about the future. We're here today. 4 years ago, it was different, trying to figure out what a cat looks like. We're here. Where do you see it going? I mean, it doesn't stop.
Absolutely.
We're not here yet, right? Where do you see it going?
Oh, it automates a lot of things in terms of how are you looking at revenue generation from your footfall in a store, right? It can help you place product placement accordingly. Earlier, we used to do consulting engagements to say, hey, people used to sit and watch people moving around and then say, okay, you have to put this product in this aisle here. These are your fast moving products. This is the best place to put them in. But it automates the whole thing now, right? So things like these, it will turn more into revenue generation. Today, we are talking about safety, security, experience,
but also asset utilization. You're keeping that asset up. You're not reactive. You're not having a catastrophic failure of the asset.
And that gives you productivity improvement, which results in more, revenue. So it's all about revenue generation. That's where we see this moving forward. The kind of automation that we can do using computer vision is going to generate tons of more money for both bottom line and top line.
When we start talking about tons of money, do you run those analytics with customers, clients, and saying, okay, we see your facility, we understand how it operates, all that stuff, and then you run some sort of modeling, and you're saying, okay, we could do this, 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 and this, and this is what we see as a value to your organization. Do you guys provide that insights, John?
We do. We definitely help. Look, what Hitachi likes to do is we're not just the seller of a product. We're partners. We're an extension of their business. That's kind of how we think about things. So as a customer grows with their challenges and their initiatives, we want to be part of that as well. Now, as you think about where things are going from the analytics perspective, we're going to continue to grow our AI-based analytics. Now, we have fundamental AI built into our video analytics right now. We're going to continue to grow that, bolster that, and then become a stronger partner with our customers. And so where we're heading for that right now is to be able to do things remotely. So we have something right now called intelligent infrastructure monitoring. So we look at core pieces of their critical infrastructure, and we could look at that video and do analytics on it from anytime, anywhere. And so looking at, whether it's a transformer, an insulator, a circuit breaker, whatever that may be, that companies currently right now spend a lot of operational expenditure on to be able to perform those inspections on. We want to be able to do that remotely. So now they could perform more inspections more accurately, reducing their OpEx.
So you bring up an interesting point, and I know that I know we're at a manufacturing conference. However, I have to touch upon it when we discuss or talk about utilities, right? Maintenance.
Oh,
and so that computer vision allows utilities to direct
absolutely
maintenance dollars in the right way.
It also, the way we are using computer vision today is to see, let's say if there is a tree growing next to a line, how tall is it? Does it need to be trimmed in order for it to not touch the wire, right? Just look at this same application. We are using it in reforestation. So we are using image processing capability.
Right.
We are using image processing capability to see how a forest is growing, put it in the context of a paper mill who is growing their own lumber to extract pulp out of it. Now they can see which portion of the forest is growing well and doesn't need fertilization and which portion needs fertilization. Earlier, it just used to be that, okay, today is fertilization day. Let me just go fertilize 1,000 acres. So now you're effectively doing 50 acres or 100 acres that need fertilization as opposed to doing the entire 1,000 acres.
But the other thing that you pull in, of course, is they're taking that analogy, that field, that forest, right? The trees, that's my feedstock into the paper. That's important to it. But it's also not just fertilization. It could be watering. It could be a number of things that
application is numerous.
Stress or whatever. Go ahead, John.
So thinking about that same premise with the infrastructure monitoring. So whether it's pipes or it's other pieces of critical infrastructure, think about if you have multiple sites. You send a team out there to do a manual inspection of these sites. How long does it take them to walk all over, climb ladders, go into certain areas, roll a truck, etc. Whereas if you had somebody from a remote monitor, like a remote monitoring station, to look at all of these, a camera could pan, tilt, zoom in on all these different areas. We could position 20 different cameras all around a site, perform the inspection instantly. And then instead of crossing between, you're walking all the way across the site and doing another piece, we could just press a button, and we're already at that camera in less than a second. And then think about when as they roll all these trucks, how long does it take them to drive in between sites? And then when is the next time that they're actually going back to that site to perform that inspection? By then, if it's on a cycle, for example, maybe once a month they go there, you may not notice that something is broken until you show up the next time or when it's already failed. Whereas you could do this inspection as often as you want, catch it before it happens, therefore reducing your OPEX and your CAPEX.
Absolutely.
Let me ask you a question real quick. And it's in line of that. Let's say I'm a manufacturer, right? And I have a facility here in Louisiana, and then I have one in Chicago, and then I have one in Tennessee, and then of course I have one up in Portland, wherever it might be. I have them all over the place, and they all sort of do the same thing. Do you have that capability of saying, okay, I've got these, assets, these manufacturing assets. I'm going to look at the performance, and then I'm going to learn from it and look at it and cross-pollinate and whatever. Can you do that, Vignesh?
Absolutely, we can. We have done it through computer models. We have done it through computer vision. When you combine both, it becomes powerful asset across both, right? So when we look at asset performance, we are looking at it at a global scale. Which plant, which equipment, which process is it running, and what stage of the process is it likely to fail?
I gotta add to that too. What about environmental conditions, right? Let's say I'm up in Portland and it's cool. And then I'm down here in Louisiana and it's miserable.
Absolutely.
And then I have the same motor pump, whatever configuration up here, but I have the same one down here. You see the same thing.
You see the same thing, but then depending on the condition under which it's operating, the parameters are varying, internal parameters are varying, right? And we are able to pick that up and then give them, exact way of maintaining them for a better efficiency. Right. So this is a combination of both computer vision and the APM.
Yes,
go ahead,
John.
And how that all comes together. So when I talked a little earlier about that holistic dashboard, that visualization suite. So geospatially, we could put all your different sites on a map, and you pick the site that you want to drill down into and look at those analytics for asset performance, or you want to perform that inspection. You pick the site, and again, you could jump from California to Florida in less than a second to do that inspection, as opposed to making calls, developing a ticket, rolling a truck, sending a team out there. You could do that. You could do all this within 5 minutes.
Excellent. Yep.
And the backbone is AI, because you're going to have to have that, and it has to keep on learning. You have to keep on adding to it. You have to keep on refining and whatever it might be, so that you continue to hone it. Do you ever sort of, for lack of a better term, cross-pollinate? Let's say my AI over here, and and it's Acme Corporation, and they have 4 sites over here, and we're learning about this pump, right? Whatever, it's a ball door, whatever it might be. So we're learning about it, and we're taking some analytics there, and you can apply that to maybe some other company and say, no, that pump performs poorly in a hot environment. I don't know. It's a use case off the top of my head, but performs poorly. We recommend something else.
Yeah, so essentially, I'll not take that exact example. So here is a real life situation. So I'm having lunch with a C-level person. So they're talking about a loading dock problem they have.
Yeah.
So they are a discrete manufacturer. Every order is fulfilled with 100 different items shipped, and when assembled at the client's end, when it is fully shipped, is when they can recognize the revenue.
There you go.
Today, they track these 100 items through RFID, but
there you go.
RFID rips off. So his problem is that when I load it, RFID rips off.
Yeah.
I do not know if it made it.
Yeah.
If the client I have to wait for the client to acknowledge that yes, they had all the parts until I can recognize the revenue.
Right.
How better can I do it? I said computer vision.
There you go.
Let us train the computer to identify 100 of these things uniquely, either through barcode or the shape and size, and let us tell you when it exits your loading dock with 100% assurance that yes, you sent the full order to them.
There you go.
Right? So that the use cases are plenty.
So if somebody's listening to me, or is listening to you guys, not me, don't listen to me. If they're listening to you and they say, hey, I'm really very interested in computer vision, how do they get a hold of you, Vignesh?
Absolutely. You can reach me at vignesh.markandan at hitachivantara.com.
Yep.
Or you can come to our booth at IMTS if you're here.
There you go.
Walk in and you will be able to, get a good demonstration of our capabilities.
I recommend that. John, how do they get a hold of you?
Similar to Vignesh, you could email me, john.smerkar at hitachivantara.com. I'm also on LinkedIn and on Twitter. You can contact me there as well, and I'll get back to you.
All right. Again, thank you very much for joining IMTS Creators Lounge. Hitachi's in the house, talking computer vision. Thank you, guys. Absolutely wonderful conversation.
Thank you.
Thank you, Scott.